Join me as I dive into the mystery of the winds that can trigger massive tsunamis and see if I can uncover the science behind this natural phenomenon. Tsunamis are often associated with the powerful forces beneath the ocean's surface, like earthquakes and volcanic eruptions. But there's another, less understood factor that can contribute to these massive waves: wind. Yes, you heard that right. Wind. It's a lesser-known trigger that can lead to devastating tsunamis. Many people think tsunamis are only caused by underwater earthquakes, but that's not entirely true. While seismic activity is a major culprit, it's not the only one. The complexity of tsunami triggers is often misunderstood, and that's where wind comes in, a factor that's frequently overlooked. Understanding the role of wind in tsunami formation is crucial, but it's also a challenge. Wind's impact on tsunamis is a bit of a mystery, and scientists are still working to unravel it. When strong winds whip up the ocean's surface, they can create a storm surge, a bulge of water that's pushed towards the coast. This surge can be just as destructive as a tsunami triggered by an earthquake. Take the 1970 Bola cyclone, for instance. This powerful storm generated a storm surge that inundated the coast of Bangladesh, causing one of the deadliest tsunamis in history. The science behind it is fascinating. Winds can transfer their energy to the water, creating a ripple effect that builds into a massive wave. And it's not just cyclones. Other unusual weather patterns like derechoes or even severe storms can also contribute to tsunami formation. The 1952 Kamchatka tsunami is another historical example where strong winds played a significant role. A combination of a storm and a submarine landslide triggered a massive wave that hit the Kamchatka Peninsula. What makes this case so intriguing is that the earthquake that occurred at the same time was relatively small, suggesting that wind and the landslide were the main culprits. Then there's the lesser-known 2013 Solomon Islands tsunami, where a combination of a storm and a landslide triggered a devastating wave. These examples highlight the importance of understanding wind's role in tsunami formation. One surprising case study that really drives home the gravity of this topic is the 2018 Palu Bay Tsunami in Indonesia. A massive wave inundated the bay, causing widespread destruction. The event was triggered by a combination of a massive earthquake and strong winds from a nearby storm. What makes this event so striking is that the scale of destruction was initially underestimated, and the role of wind was a critical factor that caught scientists off guard. This event highlights the complexity of tsunami triggers and the need for better understanding and preparedness. So, to sum it up, tsunamis aren't just caused by earthquakes and volcanic eruptions. Wind can also play a significant role. By understanding the various triggers of tsunamis, we can improve our awareness and preparedness for these natural disasters. If you're fascinated by the power of nature, as I am, I'd love to hear your thoughts on this topic in the comments below. Also, be sure to check out my other video on the science behind supervolcanoes. It's another natural phenomenon that's both awe-inspiring and terrifying.